Okay, in our next lesson here, we're again moving on more on some vectors. So now what do we need to do with vectors? So we're adding vectors. So in your notes there, it talks about if we have two vectors A and B, and to add them up. So when we add vectors, and these are the things that are missing, we put the vectors head to tail. So head to tail is how we put the vectors, and so then the sum is from the starting point to the finish. Alright, so what does that mean? Okay, so if I've got a couple of vectors, we've got this green vector here and then this orange vector there, and if I want to add those two together, then I put them head to tail. Now, it doesn't matter which one goes first, so there's that one, there's this one, and so if this was our start and that's our finishing point, then the vector addition of those is that blue one, so that's our vector sum. Alright, so in one dimension that's not too bad, and in your notes they give you the diagram, and the diagram is that you've got one that's this way, it's 15 metres east, and then we're going to add this other one which is 5 metres east, and we put them head to tail. So there's our 15 plus our 5, and so the vector sum goes from the start to the finish, and so our vector sum is 20 metres east. Alright, so example in your notes. Okay, so here it says determine the resultant force on a box that's acted upon by the following forces: 16 Newton up, 22 Newton down, 4 Newton up, 17 Newton down. Alright, so it's a couple of different ways of doing it. So here's our box, and if that's there is up. So we got one here of 16, 22 down, 4 up, and 17 down. Now, one way of doing it is to assign a direction as being positive. So here we can take up as positive. So what that means then is this 16 up is just positive 16. The 16 down, so this down one here and this down one here, the way we write those is I'll write it as minus 22. Alright, because down, if up is positive, then down is negative. Alright, so this is one way that we can deal with, and then we've got the 4 Newton up, so that's plus 4, and then the 17 down, that's minus 17. So when we add those together, 16 minus 22 plus 4 minus 17, you get minus 19. So what does that mean? Well, that means that when you add all of those together, our resultant force, and I should have mentioned what resultant means, it just means the result of adding all of those up, will be 19 Newton, and because it's negative, it will be down. Alright, so one dimension's not too bad. Now, two dimensions is something like this. So we've got two vectors, A and B, and then A plus B. So it's a bit more tricky to find these ones. Now, the good news for us is that we're not actually going to have to do ones like that diagram show. So ones that you're going to have to do, the vectors will be like so, at right angles to each other. There'll be a right angle in there somewhere. So when we add them up, so as it says there, we use Pythagoras and trigonometry. All right, so if we want to add the vectors, an example, 5 metres north and 8 metres west, for example. So what we need to do is we need to assign a direction as north. So if north is up the page, we've got 5 metres in the northerly direction. And west, so when we add, we put head to tail. So we're going to, there's with the head that's up here, I'm going to put the tail there of the 8 metres west, and it's pointing to the west 8 metres. So the sum of these, and in your notes I've used the letter Y to denote that. That's the length of that. And because that's a right angled triangle, we use our old friend Pythagoras, which is a squared plus b squared equals c squared. So y squared equals 8 squared plus 5 squared. So that's 64, 5 squared, not 52. There we go. Let's write that again. Plus 5 squared, 25, which is 89. And so y would be the square root of 89, which when you get your calculator out is 9.43 metres. Now, we then need to do a direction. So, for direction, because this 5 is north, we can say, oh well, we need to go north and then a certain angle, and it's towards the west, and that angle there, x. So in my notes on the website, I've got that arrow pointing the opposite direction to what I've just drawn. We actually want it drawn the way I've just drawn it, because we start here facing north and we turn around that way. All right, so how do we find that? Well, just that's the trigonometry bit, and so that I don't have to double up on a page, I'm going to do that up the top over here. So x would be 10 minus 1 of the opposite over the adjacent, and the opposite to where that is 8, the adjacent is 5. And so do that on your calculator and you get 58 degrees. So what is our vector sum? So our vector sum, which is y, I'm going to write it, is 9.43 metres north, 58 degrees towards the west. All right. So there's one example. I've got another example in your notes as well. So let's have a look at the next example. All right, skater is pushed by 2 others as shown in the diagram below. So there's our skater in the middle here, a ranger, and we've got 2 people pushing it. One person's pushing in that direction, the other one's pushing it in that direction. All right. So what happens? Well, what happens is those 2 vectors get added up. And so if we're going to add them up, we've got to put them head to tail, and that's what this bit over here is indicating. All right, so F1 and then plus F2, because they're at 90 degrees, that's what it looks like. So F1 here is 5 east, and so you're told they're east and north, so you know they're at 90 degrees, and that's 4. All right, so let me redraw that over here. Make it a bit bigger. 5, 4, that's Y. And this angle in here, we call that angle X. All right, so to find the size of Y, again we'll use our old friend Pythagoras. And he says that y squared would be 4 squared plus 5 squared. And so y would be 16 plus squared, I should say, 16 plus 25. So y squared would be 41. And so y, when you square root that, would be 6.4 metres. All right, we need to know a bit of an angle, and I've just noticed I made a mistake in my notes here. So on the website, the angle is worked out correctly, but the final direction I haven't. So this angle X here, to find X, tan minus 1, opposite over the adjacent, so that's 4 over 5. And when you do that in your calculator, you find that X is 38.7 degrees. All right. Now, what I've done incorrectly in the notes is I've gone, okay, so that's north up the page, and if I'm going north around towards east, I'm going that far. So I'll call that one Z. So Z would be 90 minus 38.7, which is 51.3 degrees. All right, so what the notes on the website should say is that the vector sum of those two things, which is F total, all right, that one there, F total, is there. So F total has a size of 6.4, and it's not metres. I've also got that incorrect in my notes here. I've labelled that all, both, and the diagram in the notes. I just noticed that. I've labelled them incorrectly. They should be newtons, not N, not, alright, so they're N's there, not M's, so that's incorrect. So it should be N there. Alright, so 6.4 N, which is Newton, and the direction will be north, and we are turning 51.3 degrees towards the east. Alright, so made a couple of errors with a couple of things there in the notes, but they're now fixed up. Alright, so they might still be incorrect on the notes on the website. So what I've just done here is the correct units and the correct angle. Alright, so again, that's another relatively short one. So problem set number 2. And got any questions about it? Make sure you ask.